This is a video for Edexcel Further Pure 1. Coordinate Systems 1, the Parabola and Rectangular Hyperbola. This is Section 8, Tangents and Normals. Now before you proceed with this video, it's important that you understand how to find tangents and normals to a curve using differentiation. If you haven't covered that in your pure mathematics as yet, I suggest you wait until you have done before proceeding with this particular video. However, as a recap of the ideas, we can find the equation of the line by first of all getting the gradient of the tangent, which will be equal to the derivative dy by dx evaluated at the particular x value, so in this case x1. That it can be written as f dashed of x1. Once we've got that gradient, then the straight line equation can be used. So y minus y1 is equal to gradient multiplied by x minus x1, and that will give us the equation of the tangent. The normal will have a similar equation, y minus y1 is equal to gradient of the normal multiplied by x minus x1, where we can get the gradient of the normal as being equal to -1 over the gradient of the gradient of the tangent, because these are at right angles to each other. So that slide shows that neatly written out. Make sure you fully understand it before you proceed. Now when it comes to dealing with the parabola y squared equals 4ax, you don't actually need to be able to do the differentiation for this for AS further mathematics. It will be required for A level, but not for the AS. So in all questions involving the parabola, you will be told that if the equation is y squared equal to 4ax, then the derivative dy by dx is equal to 2a over y, and you can quote this in questions. So now let's look at a typical exam question involving the parabola. Here we're asked to find the equations of the tangent and the normal to a parabola where y squared is equal to 16x and at a general point 4t squared 8t. And we're told we can reuse the result y squared equals 4ax implies that dy by dx is equal to 2a over y. Now the first thing we're going to have to evaluate then is a. So let's look at that on the next slide. If y squared is equal to 4ax, then clearly 16x means that a is equal to 4. Once we've got that, then we can evaluate the derivative at the point that we want, so that y is equal to 8t. Therefore the derivative dy by dx at our value x1 is equal to 2a, which is 2 multiplied by 4, divided by y, which is 8t, and that is equal to 1 over t. Once we've got that, then it's straightforward to say that the equation of the tangent is given by y minus y1, so that's y minus 8t, is equal to the gradient 1 over t multiplied by x minus x1, which is 4t squared. We can multiply throughout by t, and that will give us value of yt is equal to x, and then in total we'll have minus 4t squared, and then taking the minus 8t over to the right hand side, plus 8t squared. So that gives it a total of x plus 4t squared. So that's the equation of the tangent. The equation of the normal will be y minus 8t, so that's y minus y1. Now the gradient of the normal, mn, will be -1 over the gradient of the tangent, so that's going to be equal to negative t. So we get that y minus 8t is equal to negative t multiplied by x minus 4t squared, x minus x1. And therefore, rearranging that, y plus x times t, or tx, is equal to 8t. That comes from the 8t there, taken over to the right hand side, and then plus 4t cubed. So the next slide shows this again neatly, so make sure if you go through that, what we've done is we haven't had to differentiate. We've used the formula that we're given for the derivative, but then the straight line equation is used using that gradient 1 over t for the tangent, and then same straight line equation but the negative t for the gradient of the normal. Right, so now let's turn our attention to the rectangular hyperbola. For the rectangular hyperbola, then you will be required to actually do the differentiation. So remember that the rectangular hyperbola has equation xy is equal to c squared. Well, this is quite straightforward to differentiate. If we rearrange it, we can see that y is equal to c squared over x. So this is c squared x to the power minus 1. So differentiating gives negative c squared x to the power negative 2, or this formula here, negative c squared over x squared. So that will be required in any question. So you must differentiate in these situations involving the rectangular hyperbola. So here's a fairly typical question then. We're told that the point 28 P here lies on a rectangular hyperbola where the equation is xy is equal to 16, and we're asked to find the area which is made by the tangent and the normal and the x-axis, where we've got P as the point, Q and R on the x-axis. So what we'll need to do is to find the equations of the tangent and the normal. So here's t, the tangent, and here's the normal. And then to get q and r, find where they cross the x-axis. So using the equation xy is equal to 16, then, as we said before, that would mean that y is equal to 16 over x. And we can differentiate that to give dy by dx is equal to negative 16 over x squared. Given that equation for the derivative, negative 16 over x squared, that means that the gradient of the tangent at P, mt, will be equal to negative 16 over 2 squared, so that's negative 4. And therefore the tangent will have equation y minus y1, so that's y minus 8, is equal to negative 4 x minus x1, so negative 4x minus 2. We can see that if we multiply out the bracket, we will get that y is equal to negative 4x and plus 16. The gradient of the normal must be equal to 1/4, so it's negative 1 over negative 4, so 1 over 4, and therefore the equation of the normal is given by y minus 8 is equal to 1/4 of x minus 2, and if you multiply that out, we find that we get 4y is equal to x plus 30. So just pause the video for a moment, work through that, make sure you fully understand what is happening, that we've actually worked out the gradients using differentiation, and then the straight line equation to go from there. And once we've got those equations, we can evaluate the x coordinates at Q and R quite straightforwardly, because at these points here we will have that y is equal to 0 in each of the tangent and the normal respectively. So it's simply a case of putting y equal to 0 here and y equal to 0 in this one here. So looking at the tangent first of all, when y is equal to 0, you can see that 4x must be equal to 16, so x is equal to 4. And that means that at q we have on the x-axis that value 4, and the normal, when y is equal to 0, that will give us x is equal to negative 30. So this point here is at x is equal to negative 30. Now the question asked us to find the area of the triangle PQR. Well, the area is straightforward once we've got those values. Area of PQR is going to be equal to 1/2 the base. The base length is 34, so 30 plus 4, and then multiplied by the height. That's just the value of y at P. So this is the height coming in here at 8. So you have 1/2 of 30 plus 4 multiplied by 8. So that gives you 4 multiplied by 34, which is equal to 136. And there it is, again, neatly written out. So remember then, when you're dealing with the parabola, the derivative dy by dx is equal to 2a over y will always be given to you. But when you're dealing with rectangular hyperbola, then you will need to be able to differentiate the equation xy is equal to c squared. Well, that's the end of this particular video. And the next one is the last in the series where we'll look at loci problems.